Good afternoon, all. This is on behalf of Ms. Minimore Korula. I'll be talking on the application of geosynthetics on in irrigation canals with reference to one of the case study. Starting with the introduction, canal irrigation is one of the most important and cheapest form of irrigation in India. It's one of the greatest advantage of river valley regions. In canal irrigation, UP stand first in India, followed by Punjab and Haryana. And canal irrigation is of much use in the deltas of rivers like Godavari, Krishna, Kaveri and Mahanadi and the Ganges, and in coastal plains of Kerala. The role of canal irrigation for the modernization of irrigation in India is of great importance. And now, why canal lining is required? There are few requirements for due to which the canal lining is required, like to minimize the losses due to seepage, to minimize the maintenance cost, to minimize the possibility of breaching of canal, to increase the discharge capacity of canals, to prevent the weed growth and the equity of water distribution. Sources of World Bank tells that the canal lining with 1% crack area in the lining has a seepage rate of 70% of that of unlined conditions. So the canal side slopes are subjected to reverse seepage flow of water from the adjacent land towards the canal body, as you can see in the photograph. The reverse water flow exerts uplift pressure on the canal lining, and pressure release is essential. And now, what are the different types of linings which are generally used? The one is the earthen material. Historically, many of these canals have been earthen lined. Earthen canals, while relatively inexpensive to construct, lose more than 50% of water while they transport due to the seepage. And these are prone to erosion, vegetative growth, the other problems that greatly reduce their effectiveness over time. And then it's the concrete lining. The concrete canals solve the problems of erosion and weed growth, but more costly to construct and prone to cracking over a period of time, resulting in significant loss of water to seepage. In fact, the concrete lined canal may still lose 30% of water due to seepage. It has been experienced that concrete lining generally fails due to settlement of weak subgrade and pressure of water behind the lining. I'll be showing you few problems which we face due to the use of concrete linings are water loss from the canal due to seepage, damage of lining due to uplift pressure. This is occurred on especially in case of shallow groundwater tables. Damage of canal slope due to shear failure, and the broken line due to the seepage of waterlogging and uplift pressure. And then the pond formation due to leakages, rendering to the land useless. What are the shortcomings of the conventional solutions? Starting with the operational problems like seepage losses, cracks in cement concrete lining, reduced operating efficiency of canals, waterlogging in the surrounding areas, and durability issues and hence increased maintenance. And the construction problems, which include the reduced period of construction, like we will be able to do only in the non-monsoon periods, and underwater construction for the, of lining membranes, conventional lining with HDPE membranes, and concrete mattress, Gabion mattress or Renault mattress with impermeable lining, geotextile bags with lining if impermeability is required, and canal slope stabilization by reinforced soil structures and with an impermeable liner. Now we'll discuss about one of the case study that is from Haryana canal lining, wherein the application of geosynthetics and its effectiveness will be described. The major problem of the site was the prominent seepage losses and the uplift pressure on concrete lining due to high pore water pressure. Also in this area, the procurement of gravel, which was required for the filter media, was intended to be procured from 65 kilometer distance. And the solution which was adopted was using a drainage composite which performs filtration, drainage, and impermeability function at the same time. The concrete lining thickness, which was reduced to minimum stipulated as in codes, that was 3 to 4 inches, which cuts the cost of conventional drainage systems. It was simple and fast to install with a superior performance. Now, why this drainage essential? Why the drainage was essential? The groundwater table in the cutting portion was high. The lining was subjected to high pore water pressure from the surrounding soils, and the expected uplift pressure on the concrete lining necessitated the provision of a drainage arrangement underneath the lining. This was the material with a drainage composite made of a geomembrane on one side and a non-woven geotextile on the other side with a polymeric drainage core. The non-woven geotextile shall be placed on the ground side of the slope, and the geomembrane shall be placed on the concrete side of the slope. This was the typical schematic arrangement of the canal lining with a drainage arrangement. You can see the subgrade, the pore water which will be collected from the subgrade will be collected into the drainage core, and it shall pass through the drainage core, and this will be released into the canal using a pressure release valve. And this is the geomembrane on top of which the concrete lining will be done. Now, what are the techno-commercial benefits achieved? The drainage composite maintains high flow path for pore water distribution. This contributes toward the soil stability beneath the canal slopes and canal bed. It had good puncture resistance to the composite element and hence acts as a protection layer underneath the, in addition to the drainage function. The robustness of drainage composite prevents the puncturing and tearing during the installation. Typically, the drainage composite can be procured and installed at an approximate cost of 500 to 600 rupees, whereas the cost of conventional lining was around 1000 rupees per cubic meter, and this saved around 30 to 40% of that cost in terms of overall project. Now we see the installation aspects of the canal lining. The canal bed and the side slopes were well trimmed and cleared of the debris material. The side slopes were maintained at a stable slope of 1:1.5 with a vertical height of 4 meter. This was the typical sketch of the lining, and the 3-layered drainage composite was laid on the leveled slopes, and the canal bed with a layer of non-woven geotextile of drainage composite in contact with the underlying subsurface, and the layer of impermeable geomembrane in contact with concrete lining. This was the preparation of subgrade with a slope of 1:1.5 for a height of 4 meters. And the second step was laying of drainage composite. And the third photograph you can see, it's the overlapping procedure of drainage composite. As it comes in the rolls form, one roll to other roll, it is overlapped for 100 mm width. And next, after laying of the drainage composite, the next step is concreting over the drainage composite, and the connection between pressure release valve and the drainage composite. This is the typical scheme how we connect the pressure release valve with the drainage composite. All the water or pore water collected into the core of the drainage composite will be released into the canal using these pressure release valves, and these valves are placed at certain distance along the length of the canal. And this is after the this is the photograph showing the lined and unlined canal, and the two photographs which shows the canal before construction and canal after 4 years of construction. And finally, to conclude, in a dynamic environment like rivers and canals, it is preferable to choose advanced solutions over conventional materials due to their ability to take impacts, settlements, and deformations in a better way than the rigid structures. Apart from technical advantages, these solutions have number of commercial and operational features like speed and ease of construction, simple machinery involved, assured quality as per the standards, less maintenance and easy rectification if required. And these type of solutions perform in a balanced way with ecosystem and blend with environment, thereby inherently increasing the life of the structure. Thank you.